Hi, this is Mike with Apple Irrigation. I'm the Valley Center Pivot dealer in Hastings, Minnesota, and today I'd like to showcase some of the differences between the Reinke Center Pivot Irrigator and the Valley Center Pivot Irrigator. We're going to divide this video into several main parts. First, we're going to talk about the drivetrain of each machine. Then we're going to go on to the structure of each machine. Then some of the accessories such as the booster pump and the field stop. And then finally we're going to look at the pivot points and a little bit of the control panels. We're going to start with the gearbox on the Reinke. The Reinke gearbox is a Chinese made gearbox. It has a 50-to-1 gear ratio in it. It is using a very short output shaft. And one of the main things that we see because of the short output shaft is mud getting caught in this area and actually taking out the seal that's at the end of the shaft. Believe it or not, these gearboxes get really hot when they're running. They could get several hundred degrees. They're turning very slowly, but there's a lot of load going through them. And when the gearboxes heat up, the oil expands. And if there's any sort of leaks in the gearbox, like at the seals, when the gearbox cools back down, it sucks in air, and there's moisture in that air, which then causes water to get into the gearbox. So it's very important on any center pivot machine to have a good expansion chamber in the gearbox. This is the Reinke expansion chamber. It's relatively small. When we go to the valleys, I'll show you the differences and what the valley expansion chamber looks like. With the Reinke drive shafts are actually made out of 3/4 inch material. One of the things that we see is if a gearbox fails on a Reinke, the gearbox will lock up, and it'll actually take the drive shaft and twist it into this little spiral staircase railing. So now not only do you have to replace the gearbox, you've got to replace a drive shaft and maybe even sometimes a knuckle. We'll show you later that the Valley drive shafts are made out of 7/8 inch material, and that's actually designed to break the knuckle before it ruins the expensive drive shaft. Now we're going to look at the tower itself. So on the Reinke tower, we actually have just two legs on each side of the machine, and you'll notice we have steps only on one side of the machine. We're taking the load from the base beam and transmitting it up to just one point up here on the pipe. So the Reinke truss angles and truss rods are all attached again with one single bolt, as we see right up here. And again, if that one bolt is installed backwards, the entire span will probably come down. The Reinke truss angles are actually made from a pre-galvanized piece of material, and then Reinke just bends it. Well, they cut it and bend it, and when they cut it, this part of the angle never gets galvanized. It's just bare steel. And if you look at every single Reinke machine, this one's a little hard to see, but you'll see that the end of that angle has rusted. I don't know exactly what the thickness of the material on the Reinke, but I know that these angles are considerably thinner than the Valley. And then also you'll see how the truss angles are attached to the pipe by just this little tiny bracket. Alright, now we're going to go look at some of the accessories of the Reinkes. Let's follow me over to the Reinke tower box. So here we are at the top of the Reinke tower. In my other videos I talk about the differences between the Valley and the Reinke tower box. One of the things that's most annoying is the the way Reinke holds in this alignment rod. It's just a simple plastic hoop with this rod. One of the things that gives us a considerable amount of trouble is anytime we have a hailstorm. Hailstorm will actually knock these rods out, and as you can see, they fall directly to the ground. Now the machine goes out of line and safety's out. You've got to dig that rod out of the mud and put them back in before the machine will run. We're here at the Reinke field stop. This is a device that stops the machine when it's at the end of the field to prevent it from running into a tree or onto a road or something like that. The Reinke field stop mechanism uses some arms. They're attached to a spring and a cable, and it goes into this singular switch. This one switch that it's tied to is tied to the Reinke safety circuit. One of the things that's particularly annoying on the Reinke is that when this switch is depressed, you actually have to hold the safety override button to get the machine to walk away from the stop. I've actually had customers that have held the safety override to walk it away from the stop, but they've accidentally ran the machine the wrong direction and the span has toppled over. I want to show you now what the inside of this switch looks like. Inside of this switch is a singular rod with a little 1/8 inch bolt. Incidentally, here we have mice nest forming. I've had situations where this entire area has been filled with mouse nests, and mouse urine has actually rotted out this bolt. When the machine came to stop, the bolt broke off and the machine crashed. If you think about it, this one little tiny 1/8 inch machine bolt is all that's keeping the machine from crashing when it comes up to the stop. Here we are at the Reinke overhang, and as you can see, the Reinke overhang is supported by a series of truss rods right here and cables here. They're using a different combination depending on the length of overhang that they have. One of the things that I find most troublesome on a Reinke is the placement of the booster pump. As you can see, the booster pump is all the way at the end of the machine. Not only is there a lot of weight hanging out the end of here with the booster pump, but when there's a crash on an irrigator, the most likely component to receive damage is the overhang hitting a tree that has grown larger or grown up over the years. When that happens, not only do we bend this pipe, but the booster pump can get damaged. Another thing I don't like about the booster pump being way at the end like this is it's difficult to get on and work on. You've got to come out here with a ladder or a truck or a lift to get this booster pump off if it needs service. If the irrigator is ever pumping a rock, that rock will end up going all the way through this pipe and getting jammed in the booster pump. The Reinke pivot points are using a 9x9 pad. They have 4 legs, but they're using the same kind of material that they use for their tower legs, for their pivot point legs. The electrical cable that goes up the pivot point is just some mild steel, and at the very top of the pivot point, it is spinning around a seal just like this. This is actually the Reinke seal. Well, over time, this mild steel pipe will wear a groove in it like this one has, and you're going to get a leak up there. Let's take a look at the Reinke control panel. I could go on for days about the Reinke control panel, but one of the things that's most noteworthy on the Reinke panel is they don't have a lot of lightning protection in the panel. You can buy optional lightning protectors, but there isn't any lightning protection circuitry. Another thing that I don't care for on the Reinke is the way they attach the neutral and power wires. These are simple push connectors, and they just rely on pushing the wire in and making a little cut on the wire to make a good connection. For whatever reason, I see a lot of failures of these connections on Reinke machines. Here we are at the Tower of the Valley, and first thing we're going to talk about is the Valley drivetrain. I'm going to make a separate video on just the Valley gearbox, but for right now we just want to talk a little bit about the output shaft on the Valley gearbox. Valley is the only gearbox that is made in the USA. They have a big expansion diaphragm. In fact, this is a little older one. The newer ones even have a larger expansion diaphragm. And this diaphragm is designed to expand and collapse as the machine or the gearboxes heat up and cool down. There's little breather holes in the diaphragm case, and most of the moisture then is collected right in this area and never commingles with the oil in the gearbox. The output shaft on the Valley is much longer than that of the Reinke. Now you might say, well, that's going to cause quite a load on the gearbox having that longer output shaft. Actually, no. Because if you look at the distance between the center line of the gearbox and the center line of here, it's the exact same distance. The difference being is that the Valley rims are dished in. So we have a longer output shaft to keep mud from building up on the seal, and we also have a different rim that's dished in to keep the overhang load the same. On a Valley, we've got 4 sets of legs, and one of the neat things about this is that we're spreading the load over a much wider area than we are on the Reinke. If you remember, on the Reinke, we had a single point here where the legs were bolted. On the Valley, we're spreading the load out along a much larger area. One of the things I didn't show on the Reinke was the way that they attach the 2 towers to each other. On a Reinke, there's a little hook in this area, and on a Valley, there's an external ball hitch arrangement. So what's the advantage of that? Well, on a Reinke, that little hook is just a hook and a pin. If we get a big enough windstorm to blow a tower over, that hook is physically attached to the tower, and typically what happens, if you have a strong enough wind to blow down one tower, it's going to blow down the rest of them. With the Valley, it's just simply a trailer ball, and a lot of times we get a windstorm, this trailer ball will simply just flop off. One tower will come down, but the rest of the machine will stay standing. So if there is a big windstorm, pulling one tower isn't necessarily going to pull the rest of them down, but on a Reinke you definitely have that domino effect, and a majority of the towers go down. On a Valley, you can see how the truss rods are attached to the pipe. There's a gusset up here, and the truss rods are a formed head, which is just mushroomed over. Instead of using a bolt like we saw in the Reinke, it's this mushroomed over truss rod that's trapped and held up onto the pipe in this arrangement. Incidentally, you'll notice that this is a unique pipe on the Valley, and this is a unique pipe on the Valley. The reason why Valley does that is now our sprinklers are exactly spaced when we get to the tower. unlike the Reinke or other brands where putting the tower in makes the sprinklers further spaced apart. Now let's walk down and let's take a look at how the truss rods are attached. Valley uses this wraparound gusset like that to attach the truss rods. Not only do we have much more material here, but this wraparound gusset is keeping the span from trying to roll in tough crop conditions or hilly conditions. Truss angles are hot dip galvanized. They are not that pre-galvanized material that's bent. They're galvanized all the way through, as you can see here. The truss angles are a thicker material than that of the Reinke. But what I really like about the truss angles is the unique arrangement on how they're attached to the machine. We're using a plate like this, and the truss rods are physically trapped in this plate, and then the individual truss angles are bolted. This is a more expensive joint, but it's a much stronger and more durable joint. Valley has two ways of attaching the knee braces to the machine. On the model 7000, they're attaching the knee braces with this plate right to the truss angles. On the model 8000, they're using a shorter knee brace and they're attaching it directly to the pipe. As we continue further on down the machine, we're going to see the Valley Flange. Valley Flange is an 8-bolt flange using 1/2-inch bolts. Again, the Reinke was a 6-bolt flange using 7/16 bolts. I want to show you the differences close up between the two flanges. So here's a close-up view of the Reinke flange and the Valley flange. Valley uses an octagonal 8-bolt flange. Reinke is 6-bolt. Flange is actually much thicker material on the Valley versus the Reinke. Reinke and Valleys also use a different gasket arrangement. Reinkes are going to use this, I think they call it a V-ring gasket, and it fits in there like this. If I remember correctly, Reinke ships some adhesive to stick this gasket in here for assembly. Valley uses a urethane gasket that fits in the flange just like this. Here's some close-ups of the two pipes. Here is this gusset arrangement that we spoke about as to how the truss angles attach to the pipe. As you can see, it does a good job of spreading the load across the entire pipe. The purpose of this is not only to spread load, but also to prevent the span from rolling. Reinke is using this teeny gusset arrangement that's just tacked onto the side of the pipe. Another interesting fact between Valley and Reinke is the Valley seam is never going to be orientated towards the bottom of the pipe. When they make this pipe, they're actually taking a flat piece of material, running it through a very long machine that rolls the pipe and then welds it together right there. Valley seam is never going to be at the bottom. Reinke doesn't pay any attention to the orientation of their seam. In this particular case, the seam is on the bottom. That's the place where it's going to rust out first. Now let's go take a look at the Valley pivot point. Okay, so on the Valley overhang, Valley overhangs are held up with cables. And of course we have the rabbit ears on the pipe, similar to what the Reinke is. But one of the things I like most about the Valleys is the fact that the booster pump is here right at the end tower. We can walk up either side of the valley steps, easily access the booster pump, easy to work on things. And then we're taking the boosted water and running it out this hose all the way to the end of the machine. Now we don't have all that extra weight on the end of the machine, easy to work on. If the machine ever does pump a rock, it's not necessarily going to go into the booster pump. Another point I failed to mention, looking at these tower legs, is valleys have gussets at the tops of the legs. On the 7000 we have a gusset here and there, and on the 8000 we only have a singular gusset. Here we are at the valley stop box, and as you can see, we've got a square tube mounted for the end of field stop, some very heavy springs, and a steel bar, and that steel bar runs to a series of switches. What's unique about the valley stop box is a couple of things. Number one, there's some redundancy in it. The first switch will interrupt the forward motion of the machine, and if for some reason that fails, we have a second switch that will kill the safety circuit. We also have the same set of switches on the opposite side. The benefit of this is that we've got auto reverse functions in here if the panel allows for an auto reverse feature, and most importantly, with a valley stop box, if the machine is at the barricade and the arm is depressed, you do not have to hold the safety override to make the machine go in the opposite direction. And in fact, there is no way you can make it go the wrong direction by holding the safety override because of these additional switches that are contained in the box. Now let's go take a look at the barricade itself. So the valley barricade is a heavy steel structure. These square tubing goes about, I believe it's about 4 feet into the ground, and it has a stop bar up here that will depress the stop arm when the irrigator gets to the end. If for some reason the switch in the valley stop box fails, as we saw in the previous segment, we have a second switch. If that switch fails, the machine will continue in and the tire will get trapped between these two tubes and the tire will just spin out. So on the valley pivot pad, it's a 12 by 12 pad, so a little bit larger than the Reinke. Incidentally, if we poured your pad, we're going to have a ground rod in the concrete directly underneath the pivot panel. Putting a ground rod in the concrete gives a much better ground than grounds that are just driven into the sandy soil. On the valley pivot point, the pipe that goes up through the center of the pivot point is a stainless steel pipe just like this. And this gives a lot better wear resistance than the mild steel pipe used on the Reinke. Also, we have a much bigger set of seals that go around this electrical J pipe to prevent leaks. One of the other notable features of a valley pivot point is right here. There's a seal in this area that the pipe rotates around, and in the valley it's a replaceable stainless steel sleeve. So number one, it's stainless, so it's not going to wear very fast, and if it does, we can replace this rather than the entire upper elbow. Thanks for watching our video on valley versus Reinke machines. If you're in Minnesota, southern Minnesota, western Wisconsin or Iowa, you're in need of parts or service for Valley or any other brand of irrigator, get in touch with us. We'll be happy to help. Don't forget to like and subscribe, and thanks for watching.